Hello, here's another video on smart contract security. And in this one here, I want to talk about signature replay attacks. And that's actually a strange vulnerability for me, because it's sort of relatively advanced. And in fact, it's not advanced at all, but it's sort of an advanced use of cryptography within smart contracts that I wouldn't expect to find that often in smart contract audits. So I was going to talk about this in a much later video, but surprisingly I found three incidents of this vulnerability in recent contracts I audited, and these are very well-known big crypto projects. And I won't mention the names here, but it's surprising that people get this wrong, because it's really about understanding basic cryptography. But anyway, let's look at this. So first of all, what is a signature replay? Well, a very simple scenario, using public key cryptography to sign messages. Bob sends a message to Alice here, and just any signed message. And there's also Eve listening to the communication channel. And Eve just makes a copy of the signed message, which is possible if the communication channel is accessible. And then what Eve does is just resubmits this very same message. And Alice won't be able to tell the difference unless there's something in the message that identifies whether this message has been sent before or not. And this is a very typical simple cryptography scenario, because what digital signatures or cryptographic signatures do is they only identify the signer and ensure that the message has not been modified since it's been signed. So message integrity. They do nothing more. There's nothing in there that states whether a signature has been used already or a message has been sent several times. It's very basic. Very important properties, message integrity and the identity of the message origin, but it does nothing more. And that's very important to realize. And funny enough, a lot of people don't seem to realize this. And I suspect it's to do with a lot of blockchain projects not actually be written by cryptographers. Anyway, I've seen a number of examples, and this code example here is a simplification that I've simplified the code so that it fits on a single screen and reduces it to the important part. But that's a real world example that I found in a cross blockchain communication project. Basically, this allowed assets to be moved from one blockchain to another. But it's sort of a typical multi-signature scenario. And what a lot of people do is they actually have the smart contract verify signatures, because they might come from another blockchain, or they might be submitted in sort of a batch scenario for optimization purposes. But anyway, they're not submitted through individual transactions. Someone sends a bunch of signatures, for example, in a multi-signature scenario to unlock some funds, which is the case here. So in this case here, there are 5 signatures required to unlock funds of a certain user. And basically the signature properties, the signature parameters are V, R, and S, which are just the 65 bytes of a normal Ethereum compatible signature. And these signatures are created off-chain, and they are submitted in arrays here. And basically we have to check that there are at least 5 signature, and then there's some data which has been signed. So we check whether this data is actually correctly signed, and the data here is the destination address and the amount to be unlocked. So we calculate the hash, and then we loop through the signature arrays, and we verify with EC recover the hashed message, which is the destination address and the amount. So EC recover is a built-in smart contract function. It's built into Ethereum, and it verifies signatures. So basically, it recovers the address that has signed this data, and that the data is in fact correct in this message, which is hash data here, which is basically a hashed version of the message. The actual signer will have signed the same data, which is 2 and the amount. And then we just check if this is a validator for this particular operation. And if all this passes, then we have 5 valid signatures for this message. And the message is just, I repeat, send a certain amount of ether to a certain address, right? So if all this is correct, we just do that. We send the amount. It's unlocked from the smart contract. It's very important to notice what the signed message here is. It sent something to someone, nothing else. So there's nothing in this message that says whether these funds have already been unlocked, or who is the actual message sender of this particular transaction, right? So we're only submitting at least 5 signatures to a certain message. And obviously this is public on the blockchain. So you can see where the problem is. Anyone can see this message, and anyone can see the signatures, and anyone can just reuse this data and resend it. And this gives us a number of attack scenarios, but in this particular case we can think of Bob having 10 ETH locked into the smart contract. Alice is a relayer. In this case this was from as I said, this was a cross blockchain bridge where funds were locked in on one side to be freed on the other. But in any case, Alice is someone that collects signatures from authorized parties and sends them to the unlock function. So she sent these 5 signatures, and 10 ETH are sent to Bob. Now, this transaction contains the array of signature. It is publicly readable on the blockchain. So Bob can just reuse it. You can see what Alice has done for him, copy this transaction, or the data of this transaction, obviously not the whole transaction, and just create its own transaction to the unlock code, submitting again these 5 signatures to unlock 10 ETH for himself. And now he has got 20 ETH. Whereas he only had 10 ETH locked into the contract, and he can essentially repeat this until the contract runs out of funds, so he can train the contract. And so that's just very basic scenario where a signature of a message can be reused because the message doesn't include enough information. And so let's just look at how to prevent this and what are best practices. Well, of course, first of all, we have to understand how cryptography works. And this is the major problem here. A lot of people that do these off-chain signature collections and submitting them to a smart contract, they don't know how public key cryptography, how these signature schemes really work. And in this particular case, what we'd have to do is use a nonce, which is a number used only once. Basically, in this case, it could be something like a counter. And if a message has already been used, the smart contract would realize this. So in the message, we include a nonce, and this cannot be used again. So that means if the smart contract keeps track of this counter and the message is received again, it would just reject it. And that's actually how Ethereum works. Each transaction has a nonce, because otherwise anyone could just resend my transactions several times and execute them again. Another good best practice, another good thing to do is to include the address of the smart contract we are interacting with in the signed message. And this is typically done to avoid replay attacks from other blockchains. For example, someone might reuse signature submitted to a test net version of the smart contract. Much less likely, but still a risk, and easily avoidable by including the smart contract address in the signed message. So yeah, this is very important. There's some other things wrong in this piece of code I showed you. There are other things to watch out for with signatures. In particular, we have to think about address malleability, signature malleability, and this really means that a signature you can actually find several public keys or several addresses in this case that match a signature, and it's much less exploitable attack scenario, and it's really slightly more complicated, so I won't explain it now. Instead, I'll do a separate video or explaining what signature malleability is, why it is present in Ethereum in some cases, and what we can do in smart contracts to avoid it. But that will be another video. Anyway, I'll end again with a call to get your smart contracts audited. Very important. As I said, in my recent audits, I found several signature replay vulnerabilities. So yeah, get your smart contracts audited, and I will be back with another video soon.